Hey everyone. Hey John. Hey John. How's it going, guys? Hey JC. Who's JC? Hey Helmung. Hey Kadeem. Hey Joseph. Hey Julio. Oh, John Carlos. Hey John Carlos. Hey John. How was your guys' weekend? You guys get some rest? Something like that? It was snowy, yeah. The snow just keeps coming down. It's crazy. Exam tomorrow? Okay, yeah. Other of you? Okay, lots of people have exams this week. Yeah, mid-Feb, that's the time when you're dying, when you start looking forward to spring break. When is spring break? I think it's like the 11th or 12th it starts. 14th. 14th, yeah. Oh, nice. Yeah, St. Patty's Day is coming. It is a little far though. We still have we have a bit. Hey, Peter. The midterm is going to happen after spring break. It's going to be pretty short. It'll be a take home exam. I will get you more details though before you go off for spring break. That should be the least of your worries though. Project 2 is kind of what you're going to have to get done before spring break, and we're going to put all of our attention and energy on that. Okay. Hey everybody who just came in. That's okay. It's okay if you're late. And yeah, John, milestone 1 is just to be able to play in 2 browsers. Mike, you haven't missed anything. We're just chatting. All right. I am recording, it looks like already. So let's get started, guys. Today we are talking about a few things. We are going to be starting by just going over quick homework 10 recap. I don't want to go over like answers, how to do things, specific errors, things like that. My goal is just to see if there's any sorts of concepts, higher level, that I can try to explain again that related to socket or React. And then we're gonna talk about databases, how to persist data. And then we're gonna have like an independent activity where you kind of set up a database using Heroku and kind of add stuff to it with Python. And then finally, I'm gonna have give you guys some group time actually to plan out project 2 better, so that you have some steps you can take before it's due this Saturday. And that's okay, Drew. Yeah, I'm recording it and I'll post it after. So if in case you miss something, it's noted. All right, so office hours today, David has him from 2 to 3. I have him in the night, 8 to 9:30. More and more people have been coming, which is partly because the material is just harder. And also, I think I'm just in general glad to see a lot of new faces and names pop up. So I encourage everybody to come to our office hours about projects, homework, or anything. Project 1 grades, we are still grading them. It's being graded directly based on the rubric. So hopefully there's no big surprises there. And it should be out by the end of the week. And then milestone 1, again, is due this coming Saturday night. That is in 5 days. So you have to make sure that you're working on it through the week. That's going to be the main part of like my expectation with homework this week. And you do have everything you need to finish it. So you know Flask, you know React, you know Socket. So just keep working on that and building those fundamentals. What we start with today and onwards is for milestone 2, actually. So using databases. So everything that we're learning today and Thursday are actually for milestone 2. So you have everything you need for milestone 1. And yes, commit every day for sure, if you can. Okay, so how did homework 10 go? Again, I'm not going to go over like specifics with, I had this error, I can't get this to work, but I want to know, are there some concepts here that are confusing you with like updating state in React or emitting socket events, listening to socket events, things like that, that I can touch on for like a few minutes before we get into the database material? Use effect. Yes, Peter, I see that. John, think you agree? Okay, what else? Anything else? Okay, use effect. Map, sure. I can talk about map as well. All right. And use state, okay. All right, so let's start with use effect. This is a React hook, and it's basically taking in 2 different arguments. So the first argument is a function. This function here takes in no arguments. So this is a function inside of a function. I know that's confusing. You're passing in this function here, and here's the body of the function. The second argument, it's a little hidden here, is an array. So just this data structure, an array. What this use effect as a whole is saying is, I'm only going to run this function when this array updates. So right now, there's just an empty array here. So it's not really going to update after the first time. But let's say that I had a variable here, my var. Oops, let me just let some people into class. Okay. And I set it to 0. And then maybe somehow that variable is changing. Let's say let. And then later on in my code, I'm saying my var equals 5. So I've changed the variable definition. Well, when that happens, use effect is basically going to execute this function if I had my var in here. So whenever any variables inside of this array update, you're basically saying, I want to rerun this function with the newest values of my var. In our case here, we don't really need to worry about that because it's an empty array. The only thing we're saying here is that the very first time this component renders, so it like shows up on the screen, we are going to call this function and we're never going to call it again. If you remember how React is working, we aren't actually like, so this function here, this React component, this big guy, function app, blah, blah, blah. This thing is run multiple times during the course of, let's say, playing around with your app. So every time either any of these state variables changes, so we started out with just messages, that array, if that value of messages changes, or if something in the props changes, so you're passing in some props from the parent into the child, if those values change, or if the state variables change, then the function is rerun every time. And this is how we get the UI to update. So let's say messages starts out as an empty array, and then we've done some logic to update the message with like an array, and then like a string like new value. Then we're basically running through all of this code again and using the new values of state that we have. So instead of an empty array, we are using the value of the array with new value, that string inside of it, as my new messages. And we're going through all of this code, executing, executing, executing. And finally, we're returning this HTML with the newest value of messages right here. So this is how the React UI is updating on its own, because it's rerunning this function every time the state or the props changes. And then if you're showing the state or the props inside of the HTML that we're actually displaying, then you're going to automatically see it update if the values change. So that's how it's working on a high level. And use effect comes in because whenever we're doing this rerunning, there's some code that we might not want to keep executing every time we rerun the React component. And an example of that is the socket listeners. So I could actually just put this here, out here, and everything would work fine. The reason I'm putting it inside of use effect is because when you put it in here, then I only need to run this function once, socket.on, and you don't need to run it again after that. This is an optimization. So socket.on is just saying I'm establishing this rule that whenever I hear a chat from the server, I'm going to run some code. Once you've established that rule once, every time you rerun the function component, I don't need to keep saying I want to establish this rule because the rule is not changing. This function, its definition is not actually changing. I'm going to do the same thing whenever I hear a chat. So that's why if I put it out here, it's kind of inefficient to be saying, I want to establish this rule every single time that, like, let's say the messages are changing, because we already know this is the rule and this rule is not going to change. So again, you can put it out there. This is simply just a better way of writing your code so that you're not repeatedly doing something that you only need to set once. And the same thing goes for like some of these. So this is a rule that's not going to change. Again, onset username or like on-click button or something. So it's actually okay if you put some of those in there too. And then let me talk about, oh yeah, we are recording, Kadeem. When I put an array here, Nathan, then this is just this, you have to pass in an array into use effect because this is telling use effect when you should run the function, whenever anything in the array changes. Now, if you can put anything you want in there, any type of variable. I could put in messages, and that would be saying I'm only going to run this function when my messages variable changes this array. So if username changed, or like, I don't know, all these other variables I have, if those all changed, then we wouldn't actually execute this function because we're only listening for messages to change. And this is basically an effect because when something changes, say we want to run some other code based on that change, then that's how we can put it in here. So that's use effect. I am going to talk about map real quick, and then we're going to move on. And again, you know, office hours, using online documentation, things like that are going to help you with the rest. So here's an example of map. Map is doing nothing to state. Map is doing nothing to your props. Map is not actually updating anything. Map is just an easy way to basically render out a list of elements altogether. So I don't know if you remember, but when we were doing Flask with Python, we were basically doing some weird like for loop stuff. I don't know. I'm just kind of making this up. It's not the right syntax. And we would do like end for or something like that. And then we would say for every single line, we want to return a list item. And then with like data I or something. So this is how we were kind of returning back a list of information in Flask. This is the same thing that we're doing here. The difference here is it's just using JavaScript syntax and like one-line syntax, similar to how Mike said, sorry. So we're doing a similar thing here. I'm basically looping through this list, and instead of I for my index, I am directly getting the item in that list. So it's similar to like for item in messages. And then I'm saying with item, I'm going to be able to do some stuff and return something. And you also have access to the index. So you have access to the item and the index in your messages. And then you're looping through and you're returning back whatever this function here returns. So this function here is returning list item. And this is basically what we're saying. So for every single message, I want to display or create this HTML element where I'm passing in item and I'm passing in index. What's the question mark after username? Where's that? Oh, okay, here. Yeah, I'm gonna get into that next class. This is what we call conditional rendering. And you can decide whether you want to show or hide certain aspects of this UI depending on variables. So this is saying if the username is not equal null, then I'm going to display the username. Otherwise, I'm going to display some other HTML. But we don't need to get into that right now. Okay, hopefully that was helpful, but we will move on now to today's topics. And then one thing I want to mention, again, if you've run out of space on Cloud9, so maybe you've tried npm install or you've tried git clone react starter and it's saying you don't have enough space to do that, then try resizing your environment. That worked for me actually the second time. I think it works better if you have if you have more free space on your environment before you resize. So maybe delete some extra files, then try doing resizing and it might work. Otherwise, I saw that Zach had posted something useful about resizing for him, and I pinned that on the general chat. So look at Slack. And if none of that's working, then you can create a new workspace. So keep in mind, a lot of us are having to deal with this, totally normal. Here are the steps to fix it. Okay, so let's get into today's topic, which is basically how do we persist data or make it kind of last after a given session? How do we store it? If you remember this little diagram from one of our previous lectures, we were kind of laying out the full architecture of a simple web app. So far, we've actually covered a lot. We have done the front end side. So you learned how to do HTML, CSS, and in project 1, we set up our Flask web server in Python. So that was like with our app logic. And we were using request and response to basically, on our main endpoint that you request from, you are going to return back some HTML and CSS that you display. So that was our basic flow. And then after that, we started adding in JavaScript. So this allowed us to execute code on the front end as well, not just in the back end with Python, and make the site more interactive. And this is where React comes in. And then we introduced Socket, which is just another way to do like requests and responses, but using events instead. So we're kind of working within the same front end, back end, like web server type deal. But one thing that we haven't talked about here is databases. So this is kind of one of those last missing pieces that once you know about, you kind of have a good idea of the entire architecture. And it might just be more or less complex after that, but it'll be the same pieces. So project 1, we didn't have to actually save any data. We were fetching our data from external APIs, so Spotify and Genius. And Spotify and Genius were storing all of that data in their own databases for us. So we didn't have to worry about any of that side of things because they were handling it for us. But in project 2, milestone 2 is kind of going to require you to save data specific to your app. So we're no longer using external data. You need to store internal data. And this is in the form of a tic-tac-toe leaderboard. So as people are playing games on your app over the course of days, weeks, whatever, you basically want to be storing all the users who have played your game and like store a ranking for them. So based on who won, lost, or tied, you're going to update their ranking and then show a leaderboard on the side of your app accordingly. So this is what we need persistence for in order to save it, because we're not just showing the leaderboard for the current game, the current session. we want to be saving it over time as more and more people play. Elvis, we are, at least for project 2, milestone 2, we're going to be doing relational databases. If enough people are interested in it, then as an advanced topic, we could get into non-relational, which I'm going to talk about. So how do we go about persisting data? Well, there's a few different ways. The most basic way that you could do something is just like write it out to a file. So anytime you save a file with some information, that file kind of exists in your hard disk, in your memory, and you can slowly update that file with whatever you want. So an example could be a CSV or some format, special formatting. But in apps, most of the time, you're going to see a database. You've probably heard of terms like SQLite, MySQL, Redis, MongoDB, things like that. And these are kind of ways that you use more structured tables or objects in order to persist data. So we're just going to be going through like a lot of sort of definitions, terminologies before we actually code, just so you guys are all on the same page about databases. I want to ask, is databases like a requirement that you guys have taken already, or is it optional? Are you guys currently taking it? Yes, 331. Okay, taking it now, didn't take it in it. And are you guys learning SQL, or did you learn SQL? Yes. Okay, awesome. Perfect, perfect. So I am not planning on reteaching you SQL or anything like that. I'm just kind of teaching you how to build an app off of this sort of stuff. So a database is kind of an organized collection of info that you store, manage, access, things like that. And a database is kind of a service of its own. So this means that there's some computer out there, some hardware that is running the database for you. It kind of starts it, stops it, connects to other computers for you, things like that. And it's kind of like a physical thing somewhere, similar to your web server and your Heroku servers and other things like that. So there's relational and non-relational databases. Relational is kind of what we usually refer to with SQL languages. And they're basically storing your data in terms of tables. So it's going to be interlinked tables, similar to Excel. You might have something like on Instagram, you have a table for users, and then you have a separate table for all the posts. And then you can kind of link which posts certain users have made using different tables like that. And SQL is basically a language, a query language that you use in order to actually ask for data from that table. And let's see. So non-relational databases, that includes MongoDB, you've probably heard of, Cassandra. These are not stored in tables necessarily. There's no kind of defined structure for it. But they don't use, like either way, they don't use SQL to query it. MongoDB is kind of what we call document-based. So if you remember how we kind of wrote JSON formats and like use JSON format from Spotify and Genius, those kind of blobs of JSON are actually an individual row in our MongoDB table, basically. So that's what we call document-based. And then there's something like Redis and others that are key value based. So just a huge dictionary of information with keys and values. So there's different ways of doing non-relational, but those are like the most common. Based on this though, what do you guys think is a benefit of doing non-relational over relational? So what's the benefit of kind of having something more unstructured, not requiring a table format, and being able to use like key values or something like that instead? Any guesses? Any ideas? Maybe time. Okay. That's possible. Key value searches are often really fast compared to like maybe iterating through something similar to like hash tables, right? Exactly. Easier to insert data. I think that's something important that I'm going to touch on. A little more versatile. You can mold it without much restriction. So kind of easier to insert data and versatility. Those are two things that you'll hear most commonly when somebody says, hey, I want to go with MongoDB for our database. And the theme, overarching theme with that is flexibility. The benefit of something like MongoDB is that let's say that you have a startup where your data requirements are changing really fast. You don't exactly know what you're building fully, and maybe you have to store different fields that you didn't really expect when you first designed that table or that database. The benefit of this sort of structure, like a JSON structure or something, is that you can slowly add new fields to your documents or rows in the table. And it's okay if you do that like later on, once you've already built the database. And you won't need to do like a full migration of your table. So when something is in a more tabular format, then adding columns to that table is actually a little more painful because you're basically saying all the past rows that are all the existing rows in this table, they now need a value for that new column that I've added. And if I don't do that, then that can kind of break the structure where every row of the table has all of the columns filled out. So when you're kind of dealing with something less structured with keys and values, you can just add new keys, new values, and not all of the documents in that database need to have the same keys and values, which allows you to iterate faster depending on data requirements. What about relationally though? What is a benefit of, oops, where is it? Okay, I can't find the slide, but what's the benefit of doing a relational database system over non-relational? Of using tables? Any guesses? So right now we were talking about non-relational databases and why you might choose that instead of relational. But what about the flip side? Why might you want to store things in a more structured table format instead of a less structured kind of maybe JSON blob or key values? Data integrity. Yeah, so you can enforce things a lot better with that structure, which means that you probably have better organized data. You kind of know when I'm looking at any given row in that table that I can be satisfied and know that it's going to have values for every single column in that table if that's my rule. So you have more rules there, and this can be more reliable. In MongoDB or something, maybe I'm accessing one blob of JSON, but I don't necessarily know what keys it has, what values it has, because these things are changing fast and you can update them so easily. Another one I think is storage. I think it's actually a lot more efficient to store a table in that format than, let's say, these blobs. And yeah, that's a good one, Elvis. So you have interlinked tables. So you ensure there's no duplicates, and also, right, yeah, if you change it somewhere, then you can kind of use those links between tables to delete something everywhere. Right. Okay, so yeah, there's a lot of options here when it comes to databases. It really depends on your, again, that's kind of the answer whenever we're talking about trade-offs. It all depends on like your specific requirements, what you value more. Do you want better organization? Do you want to be able to move faster? Things like that. And one of the things that's going to come down to is just like ease of use. What is your data looking like? What kind of structure is it showing? Does it fit nicely into a table? Or does it seem a little less structured where it's going to change and you need like some sort of blobs or objects? In Most cases, though, you're going to be joining a company where they've decided that a long time ago, and you just kind of have to roll with what they're doing. But as an engineer, you should understand the benefits and the trade-offs, and kind of have insight into why they would go one way over the other. So in our project too, we're going to be using Postgres, which is relational. So here I just had some quick database like refresher topics about relational ones. Every table needs to have a primary key, which is kind of uniquely identifying a given row in that table. And then a row in that table is kind of what we call a record. And that record is going to have a value or something for every single field, which is like the column in that table. And again, if you've taken, I guess, 331, this shouldn't be anything new. And then finally, you have the columns, which are kind of representing the field. And the field is kind of one specific attribute for that row or record. Okay. So as I said, we're going to be using Postgres in this class. The main reason before I even get into it is just that it's super easy to make using Heroku. Heroku can store it for us, things like that, and we can configure it nicely and work with Python. So it all had to do with ease of use in this case. So Postgres is what we call like a DBMS, or a database management system. It's basically going to store your data in a certain format. So in these tables, and it's going to make that data accessible to you using the SQL query language. And this is basically a service that is being run somewhere. We, like from our web app side, we're going to have to connect to the service in order to update that database or create the database or do anything we want to it. So like I mentioned, Heroku makes this a lot easier for us. If you think about our app code, like in project one, you could either run it locally or you could run it remotely on the larger internet. To do it remotely, you needed to deploy it using Heroku. So very similar to that, our databases are also like a service that can be run locally on Cloud9 or on the larger internet, which is like a remote database. So when we deploy our app for project 2 onto the internet, it's not going to have access to a local database on Cloud9. We need this database to also be accessible over the internet remotely. So this is where Heroku Postgres comes into play. In this class, we are only going to work with remote databases instead of creating something locally first, just to kind of take out some steps of the workflow and make this faster for us. But what was I going to say? Yeah, you can kind of think of it as like either hosting your code, let's say, on your own Cloud9 versus putting something onto GitHub. Okay, a few more slides of terminology, and then you're going to actually try some stuff out. So once we have like a Postgres database set up, we actually want to be able to make updates to it and changes to it. And because we're doing all of this within a web app, it's a pain to have to do it all using like SQL statements and stuff like that. It's a lot easier to be able to do it directly inside of our Python code. Now, when we connect to our Postgres database, we can't listen to it or like talk to it using HTTP. So we can't do like requests.get in order to get our data from there. There's a separate sort of protocol that we have to deal with here called a custom database connection. All of this is going to be abstracted out for us, though, using something called psychopg2. And then one layer above that we are also going to be using something called SQL alchemy. And this is going to abstract away the need to write SQL queries. And it's going to actually take our database that whatever we have stored and map it out into Python objects. So SQL alchemy is what we call an ORM, or an object relational mapper. And it's going to translate, in this case, our Postgres database, so the rows, the records, the columns, into a Python object. And this actually makes it a lot easier to, let's say, add a field, create a new table, do all sorts of stuff. And it's exactly like an API. It's basically creating an API that makes it easier to interface with a table by using Python code that we're used to, such as updating objects. And the way it can do that is using something called a model. And this is a class where you define different properties of that class, and those properties are mapped out to certain columns on your table. And this is going to make it a lot more intuitive, hopefully, and natural for a web programmer to work with a database. Usually at a lot of companies, you're going to see that they use some sort of ORM instead of making their full stack engineers directly interface with a database. So we similarly do this with Facebook. We're not using SQL Alchemy, but we use an internal kind of library that helps us update the Facebook database. This makes things a lot cleaner for the engineers, and also helps us from kind of making mistakes. So maybe you don't know SQL the best and you're more of a Python person, then you can kind of trust that the library is going to handle stuff for you. You don't need to know all the specifics about data engineering in order to work with a database. So all these pieces together, we have a DBMS, which is Postgres. We're querying that. We can query that using SQL. This DB is hosted remotely on Heroku. And we can access and update the DB using Flask SQL Alchemy, which you had to install in the last homework, so you should have that already on your Cloud9. One thing I didn't mention is there's also a kind of command called PSQL, and this can allow you to very quickly from your terminal directly see what's in the database and do actual SQL queries and statements like that in order to see all the data in there. So that's also a useful thing that you're going to use. But to actually make updates through our web app logic, we're going to use SQL Alchemy. Okay, so I just talked for a while at you guys. Now I want you to just try out and set up some stuff on your own. So I'm going to send you this link. And basically what we're going to be doing is we are going to create a new database with Heroku. And then we're going to connect that database to our Python code. And then we're going to use Python code to actually make updates to that database. And then finally, we're going to just double check to make sure that the updates happened. So there's nothing truly crazy, groundbreaking happening when you go through this, but it's just showing you the flow about how Python and Postgres work together. And then next class, we're actually going to get deeper into how to make this more functional in terms of a web app. So I am sending this over. I'm going to give you all 15 minutes to get through as many steps as you can. And then whatever is left is just going to be homework. But it shouldn't be too long and it shouldn't be too hard. It's more just about getting this flow and understanding it. So ask me any questions as you're going through it. 15 minutes. I gave the link in the chat. We'll be back at 1:23. Shell, that's okay if you're on your phone. You can just chill for 15 minutes, and this is basically going to be what you have to do for homework then. Yeah, John, it's totally fine if you want to separate that out. Um, it might be easier for you, so whatever works. Nope, I don't need to see any of the code that you do here. That's why you're copy pasting it into Canvas. Yep. Natham, it just depends like what those changes are. So if you made changes that are related to your project too, then you can commit them on that branch. This is just so that you are kind of working, you don't carry those changes that you made over into here. Does that make sense? Okay. Kadeem, so you guys can all ignore the SQL.end file actually. That was only if we were doing local work, but we're going straight to Heroku, so you can delete that. Don't worry about where it is. Gerard, if you've hit your limit, try just deleting a bunch. What is the limit? How'd you hit that? John, Heroku PGP SQL is in the terminal, not Python. Elijah, I'm not sure what your question is about guest and admin names. Okay. Two more minutes, then we'll come back. It's okay if you're not done or if you're not close to done. Julio, so when you run Heroku config, it's going to show you all those variables. You want to take the variable that is set to database URL and just copy paste that value. So it's going to look something like Postgres, bunch of numbers, this big link basically. And John, you don't actually need to do anything with committing and pushing. You can, if you want to push this up online. This app doesn't do anything yet. This is mainly just to get something working using your Heroku database. And yeah, totally add PyCache to git ignore. It's a pain. Okay, guys. What step are we on? Who's done? Who's on what step? Let me know in the chat so I can get a sense of how far we all got. Okay, Nakib said he's done. Venkat said done. Elijah's on the last step. Descartes done. What else? For those who aren't done, what step are you currently on? Last step? Okay. Finished. Okay. The rest of this is just for homework. You don't need to do anything further than this. Just follow these instructions and finish that for homework. And then we're going to actually kind of make stuff happen in our app itself using this database. Today was more about getting it all set up. I'm keeping it light just because I know project work should be taking more precedent. Okay, Gerard, almost done. Cool, cool. Okay, I want to touch on something just in the code that we're adding because you guys were just copy pasting it for now. This line that you see here on my screen is setting the SQL Alchemy URI, so like what your SQL Alchemy code is going to point to, what database it's going to point to. So that could be a local database. In this class, we're pointing it directly to our Heroku database that we created remotely. That's why you needed to do export database URL, because we get that environment variable here in this line of code. And then this db equals SQL Alchemy app, this is kind of what actually creates this variable that you can then use to access the database and connect to it and make changes to it, things like that. And let's see. One thing important here is, so how did this database actually get created and know what sort of schema to build with? So how did the database get created? First of all, we did db.createAll, and that's what actually took something out of, or created something out of nothing by creating a new table inside of your Heroku database. And then we were basically creating instances of this person class that we've defined, adding it, and then you needed to commit it at the end. That's the only way that we actually save those changes to our official database. So you always are going to have to go through this flow in your Python code when you want to add some info to your database. Now let's look a little bit more at this person class. It is taking in DB as a kind of, it's basically extending this db.model when it's defined. And this allows us to basically tell what we want this person table, so it's called person, to look like inside of our DB database. So the database can have multiple tables in it. We're just talking about one here called person, and it's going to have 3 columns in it. So remember, we're doing a table format. It's relational. First one is ID. That's the primary key. It's kind of automatically set as an ID whenever we create a new person. You have a username and then an email, which are both strings. They have to be unique. They can't be nullable, things like that. So this is how you set all the metadata for what your table is going to look like. This doesn't create the table. This is just the schema for it. And then you're actually going to create it when you do something like db.createAll. So now you have a Heroku database created, working, and you added some information to it using Python. We weren't doing this directly inside of our app.py code yet, or our actual like web app logic. That's kind of going to be what we talk about next class on Thursday. Okay. All right. So let's move on now. Again, please come back to Zoom if you're finishing up. You can finish that for homework. So we're going to pivot now to talking about project 2, specifically milestone 1. What I know it's like a lot to kind of think about all at once. So I want to stress something. Every good engineer, like before they start working on something, they go through a planning phase. So you got to think about like what the end goal is. What are the steps you're going to need to take in order to reach that end goal? And then you finally jump into actually coding up whatever the specs are. So you really shouldn't be like just kind of jumping right in and trying to do everything in the project unless you understand of like what, if you have a good understanding of what it's going to look like at the end and like what kind of steps are going to be needed for it. Obviously there's trial and error through it, but you need some aspect of planning. Another thing is you don't need to plan the entire project all at once. You always want to be like breaking down your project into smaller, more digestible pieces. And that's going to make it less overwhelming for you and also allow you to plan it more modularly, thinking in small chunks of phases. So we're now going to do like a group activity where we go through this planning phase in groups of like 5. And I want you to basically map out all you think that needs to be done in your code in order to satisfy one of the requirements on the spec. So here's what's going to look like. And I basically have broken down all the requirements or like the specs in the actual specs, bullet by bullet. So each room that you get into, or like the one room that you're a part of, is going to be assigned one of these kind of specs to look at. And I want you to think about like, what is the flow going to look like in order to implement it? Do we need React? Do we need to have state stored? Do we need some communication between the client and the server with socket? What kinds of events would we need? Things like that. And also like, what do we need to display on the UI? So yeah, groups of 5. I'm going to open up the rooms and basically start by introducing yourselves. Maybe if you want, somebody can volunteer like to take the notes and write the stuff down, and then just go ahead and discuss. And this is definitely like what we do in the real world when we start a project. We kind of just bang stuff out with other people and like try to figure out what steps we're going to need to take before we code. Remember your breakout room number when I open them. I'm going to open them now. That's the room that is going to map to like what spec you have to work on. All right. You're going to have about 15 minutes. So take your time, get to know each other, and hopefully this is useful. Okay, join your room. Oops. Wait, sorry guys. I realized I didn't give you the link to actually go to the doc. So let me send that in the chat. My bad. Okay, so check the chat. Join this Google Doc, and that's where you're going to be working. You need access? Oh, shoot.
Yeah.
Let me do that.
Yeah, I need access too.
Okay. Try it now.
Yeah, it works.
Working?
It's good now.
Okay, perfect. I'm going to reopen them and send you back out. For those who just came back, I was calling you back just to have access to the link. So I just sent that in the chat. Take a look at that, and then I'm opening the rooms back up so you can join in again. Malachi, Brian, join your rooms. John, join your room. Brian, Malachi, John, you guys still haven't joined your room. Hey, child. What room were you in? I can put you back. Okay, welcome back in, everybody. Looks like half of you are in the rooms, half of you are here. So let's wait for everyone to come back. Yeah, Doc got messed up a bit. I saw that table moving around a lot. Okay. All right. Welcome back in, everybody. Okay, how was that? I'm hoping that this was helpful. Yeah, whoever resized. I guess we have the version history to look at that. But anyway, okay, yeah, I think I'm hoping that this was helpful for you guys. You were able to think a little bit more about how to break things down and also just talk to each other. Sometimes things don't make sense in your head, but uh, asking other people about it clears it up for yourself too. Good, okay. Mike said it was helpful. John Carlos thought it was fun. Good, good, good. Okay, so it's 1:51, I know. So that was it for the day. I'm going to be looking through and I will, this is your doc now, guys. You can add more to it as you learn more things and maybe think of new approaches. So this is for you guys to help each other and make project 2 easier for you. So you guys go through it. I'm not going to give you answers, but I will steer you away if you're completely on the wrong end of things. But otherwise, let me just finish up. Homework 11, it's just finishing those instructions that you went through earlier, if you didn't already, and posting the screenshot of the SQL query on Canvas. And then work on project 2. Next class, we are going to be doing 2 things. One is going over just like React and Socket and like any questions you guys have. And then the other half is going to be going deeper into databases. So come with questions, come with confusions, and we can talk about them. And that is it. I will stay back for 5 minutes if you guys have questions, but otherwise, have a good week and I'll see you guys Thursday.
Professor, fast question.
You guys. Yep. What's up, Julio?
So the extra credit, is it just for milestone 1 or all project 2?
We'll grade the extra credit at the very end. So
Okay, so I don't need to do that for milestone 1 at least.
no. You do have to have it in by milestone 3 though.
Okay.
All right. Take care, guys. Bye. Bye, Elijah. Bye, Philip.
I had a question about our environments.
Yeah, what's up?
When you say create a new environment, do you just like, are we supposed to leave it at the same like base 10 gigabytes?
You can try increasing it actually, maybe like 15, 20.
Okay, no problem. That was it.
Okay, yeah.
Hey, Professor, I want to ask you, I wasn't able to finish homework 10. Would I still be able to submit it if I finish it?
Yeah, so John, homework 10, submit it. You can always submit everything after the deadline for half credit. I'd only extended homework 9, but homework 10, I haven't given any extension unless you have like a specific reason. Yeah.
Okay, and then I also want to ask you, so for milestone 1, it's basically like homework 10 be able to play in 2 browsers?
Yes, exactly. That's exactly what you want, to be able to do it in both.
And then do we have to display the winner and loser too for milestone 1?
Yep. So all of it, again, like look through the milestone 1 specs carefully and you'll see even in the rubric at the end, just like all the things that we're going to be grading based off.
Okay, all right, thank you.
Take care, John.
Professor, I do have an error, like one second.
Hey, Ashwin. Yeah, what's up?
Oh yeah, this is my error. So when I want to like change my use state hook, since it is an array using a map, it shows this.
Okay, have you tried Googling this issue?
Yeah, it's been like 2 days since I started Googling.
Oh, really? And what's happening when you try? What's it showing?
It's the same thing. There's no use.
But when you try to Google, like what are Stack Overflow posts saying is wrong with your code?
Yeah, people say like I should like return it like using parentheses like an implicit return, but when I try it, it's of no use. So
Okay, why don't you show me your code right now?
sure.
Kadeem, did you have any questions also?
Yeah, could you see my